Example's a little different as they give us one of the complex zeros. So they tell us the complex 0, 1 minus 2i is a 0 of this polynomial. We need to find the other remaining zeros and do the linear factorization, and then also write it as a product of linear factors and irreducible quadratics, which really essentially means to use real numbers. From the graph, we can see that there are no real zeros of this polynomial, so everything is going to be complex. So we're going to start with the 0 that they gave us. So first of all, we have zeros of 1 minus 2i, which was given. We also know 1 plus 2i would be a 0 because we know that complex zeros come in conjugate pairs. Then we need to find the other 2 because we know that there's 4 from the fundamental theorem of algebra since this is a degree 4 polynomial. So we're going to do synthetic division with the imaginary numbers. Remember that your calculator will do the complex arithmetic for you, so you can use that. So I'm going to start by dividing by one of my complex zeros. I use the 1 plus 2i. So I got the 4. I need to put the 0 term in for the cubic term, and then my quadratic term is 17, my linear term is 14, and then my constant term is 65. So we're going to bring down the 4. Then I'm going to multiply, and this is going to give me 4 plus 8i. Add that to 0, so that's 4 plus 8i. So again, remember, if you want to use your calculator to do this, check your mode, and you want to come down to this line that starts out real, and you want to be in the a plus bi mode. We're going to do 1 plus 2i. Remember to put those in parentheses, so I've got 1 plus I, so second decimal point is the I, and then times, and then we've got 4 plus 8i. So that gives us negative 12 plus 16i. So adding these together, this is going to give us 5 plus 16i. Calculator if I want. So add the 17 to that. And we've got that, and then we're going to multiply by the 1 plus 2i. And here we get negative 27 plus 26i. So I've got negative 13 plus 26i. Multiplying that times the 1 plus 2i. Gives us negative 65, which gives me 0, which is what I'm looking for. So this is looking a little bit ugly, but it's going to work out. So next I'm going to divide by my other 0, which is 1 minus 2i. So then I'm going to bring down the 4. Then this is going to give me 4 minus 8i. So the 8i's are going to cancel out, and I'm going to have 4 plus 4, which is going to give me 8. So then this is going to give me 8 minus 16i. Again, the i's are going to cancel out. 5 plus 8 is going to give me 13. And then this is going to give me 13 minus 26i, which will all cancel out and give me 0. And then we're left with 4x squared plus 8x plus 13, and I want to extract the zeros from that, so I'm going to set this equal to 0. I'm going to use the quadratic formula here. So x is negative 8 plus or minus the square root 8 squared minus 4 times 13 all over 2 times 4. So we end up with x equals negative 8 plus or minus the square root of negative 144 over 8. So that's going to give me negative 8 plus or minus, this is going to give me 12i over 8, which will give me negative 1 plus or minus, dividing both of those by 4, we're going to get 3/2 I. So in part A, remember it asks for the zeros and the x-intercepts. We know there are no x-intercepts. And then my zeros are the 1 minus 2i, which was given, the 1 plus 2i, which we knew from complex conjugate pairs. Then I've got negative 1 plus 3/2 I negative 1 minus 3/2 I. Part B asks for the linear factorization, so f of x equals, my leading coefficient was 4, so we're going to start with that. And then I'm going to have x minus 1 plus 2i, x minus 1 minus 2i, x plus 1 minus 3/2 I, and x plus 1 plus 3/2 I. Part C asked us to write it as a product of linear factors and irreducible quadratics. So remember that essentially means we can't use any complex numbers. So we want to use a factor of the set of real numbers. So over the real numbers, I've got the 4. I'm going to multiply these two terms together. So that's going to give me x squared minus x minus 2xi minus x plus 1 plus 2i, and then plus 2xi minus 2 minus 4i squared times, I'm going to multiply the second two terms together there, and that's going to give me x squared plus x plus 3/2 xi plus x plus 1 plus 3/2 I minus 3/2 xi minus 3/2 I minus 9/4 I squared. 3/2 xi, negative 3/2 xi are going to cancel out. 3/2 I and the negative 3/2 I are going to cancel out. Up here, the negative 2xi and the positive 2xi are going to cancel out. This term should have an I on it, sorry. 2i and negative 2i are going to cancel out. So up here, I'm going to have x squared minus 2x, and I've got 1 here, and this is going to give me plus 4. So it's going to give me plus 5. Here I've got x squared, I've got 2 x's in there. And then here I've got the 1, and then this is going to give me plus 9/4. So that's going to give me plus 13/4. Or, if we don't want to have this fraction in here, I can take this 4 and distribute it into this parenthesis. And we would have x squared minus 2x plus 5, 4x squared plus 8x plus 13.